It's my pleasure to be here with you. We're going to do a joint talk, me and Dion, and we'll introduce ourselves. But you know, there's so much of talk on AI. AI as being a part of our daily lives. AI as being applied in different type of industries, being applied in so many applications. So what does all that mean when we talk about the partnership between NVIDIA and Schneider Electric? That's going to be what we want to talk about today. So I'm going to quickly get started. Meeting tomorrow's demands today through AI. My name is Pankaj Sharma. I'm the EVP of the Secure Power Division and the data center business for Schneider Electric. And I have here with me, Dion.
Yep. Hi, I'm Dion Harris. I'm the Director of Accelerated Data Center Go-to-Market at NVIDIA.
Thank you, Dion.
Yep.
So look, this is one quote which is one of my favorite quotes in the last couple of months. And obviously, the individual Jensen doesn't need any introduction. But there's something which he says there. Look at what it says. It says, generative AI is the defining technology of our time. Fair. But working with most dynamic companies in the world, we'll realize the promise of AI for every industry. Now, this is one quote which stuck with me, and I think this is one which we need to remember, and we should keep coming back to this in actually every few years, especially in the next 3 to 4 years, when a lot of training of the AI clusters would actually have been deployed. So again, taking a quick step back, what does that really mean? When we talk about generative AI, we talk about two portions of generative AI. We talk about the development or the training, and then we talk about inference. Now, training is where billions of parameters on large language models are getting trained for the AI cluster. Inference is where information from that is compressed and utilized in the day-to-day functioning of different applications and industries. You know, there's one example there of the self-driving cars. Now, it's interesting when you think about a self-driving car, all the data that is getting generated is all getting trained. But eventually, when the motion of self-driving starts to get better, that's where inference comes into play. So huge opportunity in various industries. But with that, maybe, Dion, I'll ask you this question. Yeah. What does this mean from a technology standpoint?
Yeah, sure. Thank you. So, you know, from NVIDIA's standpoint, you know, we spend a lot of time working with customers to figure out how and where they can deploy AI to gain benefit. And it's happening across a myriad of different industries, scientific domains, and what's really exciting is AI is really transforming sort of the viewpoint of the data center. It's no longer just a cost center, it's really about, it's an AI factory and it's generating real insight, real value to the business. Yeah. And so, you know, this next slide really just highlights a couple of examples. And whether you're talking about you looking at weather forecasting and modeling, that's a key area where you need highly dynamic, real-time information based on forecast data. And so there's lots of AI surrogate models that are being developed to help improve the overall performance, accuracy, and reliability of those. In fact, we've done some work recently with a model called ForecastNet. We're able to improve the overall efficiency of that modeling capability by about 12,000x. So those are the type of numbers that you're seeing, orders of magnitudes that are improving the overall business value. You're looking at car design, automotive, that are using AI to explore different design parameters. You're also seeing things in terms of drug discovery. We're just here coming out of COVID, right? And we're now here in person and we can sit next to each other. But a lot of that groundbreaking research was done using computer-aided drug design. And so we're seeing examples of using AI like AlphaFold to predict protein folding. And so again, the use cases are very widespread. And the key thing here is that this is what's driving the excitement around AI, is being able to get real value that can translate either into real opportunities for improving overall operations, efficiency, or even revenue opportunities.
Revenue opportunity. Yeah.
Yep.
Yeah, that's great.
And so tell me, I mean, right now I think, you know, we talked a little bit about what's happening in terms of the workloads for applications and use cases. How is this impacting the data center workloads?
Yeah, and that's a great point, because if you think about all of these applications, end of the day, they have to run on data centers, which is where all the compute is happening. Now, when you think about the opportunity and the way the workloads are shifting, there's some important information here for you. When you think about AI, it's about 4.3 gigawatt today in terms of the total AI workload. that is expected to go at least 3 to 4 times, so almost 15 to 18 gigawatt just in the next 3 to 4 years. The total power getting consumed from about 8% today to almost 15 to 20%, even with all the efficiency which is getting built in, because the multiplication is happening on the powertrain. And finally, another important point, when you think about the AI workload today, 95% of that is in the central or very large data centers, but that's expected to go to almost 50%, because the 50% will move to inference or to the edge, as we like to call it. So some important information to think about on how this demand is actually shaping up. But now again, Dion, back to you. The AI models, end of the day, the AI models are the ones which are driving this need for high compute. So maybe you want to talk to that a bit.
Absolutely. This is no surprise to anyone in the audience, but this space is moving exceptionally fast. When you look at sort of, how far we've come in such a very short time, a lot of it is driven by all the activity that's happening in the development community, the framework developers, but it's really forcing us as infrastructure providers, technology providers, to really sort of leapfrog ourselves in order to keep up with that demand. In fact, if we just take a look back and see where we've been in terms of AI and the journey we've been on, when you think about the early stages of AI, it was really about image recognition, how you can use AI to do interesting research-based tasks. And that was useful, starting to really unlock some of the use cases around how AI could be useful. But there was an iPhone moment that happened in the last couple of years. It was the introduction of the transformer. In fact, it was based on a real interesting research paper that was called "Attention is All You Need." And there's a key mechanism of transformers that leverages attention to help create that accuracy and reliability that you can get out of the results from some of these AI models. And what you can see is that over time, we've seen these models continue to grow in size and capability. So, you think early on, you might have had a model that was a couple billion parameters. ChatGPT-3, which we all know and love and have used, I'm sure, in a lot of our daily lives, is roughly 175 billion parameters. Now, if you fast forward to where we are today, a lot of the larger models are actually in the trillions of parameters. And so what that means is a couple of key things. One is you need more compute. Right, in order to process and navigate that parameter space of 175 billion to trillions of parameters, you need a lot more infrastructure to really understand and be able to use that. The other thing that it has really created is forced the development community to look at new approaches to leveraging all of those parameters. So there's a model called mixture of experts. And what that does is, more recently, in order to go and tackle those multi-trillion parameter models, it splits those, they call them experts, across multiple systems, multiple GPUs, and allows them to interact in parallel. Now, the one thing that's unique about that is it reduces the compute requirement, but it also increases the communication. And so they need to share data across the GPUs, across the system, and so that now introduces a new system challenge, if we will, in terms of deploying those models. And so a couple weeks ago at GTC, we announced our NVIDIA GB200 NVL72. And what this is, it's looking at sort of these new cutting edge models, and it's trying to understand how can we remove that sort of network communication bottleneck to make sure that they're communicating as fast and efficiently as possible. And so NVL72 has a couple of key innovations that I'll highlight. There's a number in the platform, but for today we'll highlight a couple. The first is what we call our multi-node NVLink. And so this is basically connecting 72 Blackwell GPUs along with 36 Grace CPUs, all connected over NVLink. And so this is at full line rate, 1.8 terabytes a second. Wow. And the reason why that's important is because it allows this to behave as a single GPU. So you have this fully integrated system that allows you to have full access to all the data that's on all the GPUs. The other thing that's really key here is that this is a liquid cooled system. In order to get this incredibly power and compute dense infrastructure, it had to be very efficiently cooled and architected. And so that's a little bit of what we'll talk about here today as well. But this is a full exabyte of performance in a single rack. And so this is how far we've come. If you were at any of these conferences 4 or 5 years ago, the whole sort of moonshot was getting to an exabyte scale system that would fit sort of in a data center. But this is a single rack that's delivering an exabyte of performance. The other key thing that I'll highlight here is as you look at sort of the state of the art today, it's Hopper, right? And we've been really powering a lot of these great generative AI models using our previous gen platform. And again, this is something that is powering the AI factory of today. If you look at a 1.8 trillion parameter model, you can see that roughly a 30 kilowatt data center can deliver about 55,000 tokens. And again, that means real revenue, real opportunities for operations to be built on top of AI. Our next gen platform takes that and shrinks that in terms of footprint, in terms of overall productivity of the system, and now you can get over 30x more performance out of that same system. So this is an incredible opportunity for customers who are power constrained, who are space constrained, who are trying to get the most out of their existing power envelope and data center resources to get even more performance. And that's what we're trying to do, to get ahead of that demand, to make sure that we can deliver that in the most efficient performance and envelope, performance and power envelope as possible. So here we have, NVIDIA is building our own data center based on this architecture that I just outlined. And we're retrofitting existing data centers to be able to handle the power, the space requirements, the weight requirements, understanding that it takes a new planning and methodology and thought process to basically adopt these new technologies. And so we're working with partners like Schneider and Electric to make sure that we're building out platforms that will allow us to build out our data centers in a thoughtful process so that we can get this system up and running. And as you see here, as this build out, we're leveraging a digital twin platform to do a lot of this complex planning, because you need to understand how all these pieces fit together before you can actually use and deploy these systems.
Awesome. Well, thank you, Dion. This is great. So a few things which I learned from you today and in the past days is the AI models, the mixture of experts. If there's one thing which all of us want to learn and take away from here is the defining the most latest of the latest. You also made a very important point around retrofitting existing data centers, because we keep hearing about this a lot. So it's not only building new data centers, it's also ability to retrofit. And then finally, of course, the reality of the density. When you think about going from just the last version to the GB200 version, density. Now, all of this, Dion, also has a big impact on the infrastructure, the physical infrastructure.
Absolutely, yes. I love to hear a little bit about what you guys are doing on the infrastructure side to get ready for all this technology that's coming.
Exactly. So let me take a minute to talk to the infrastructure part. Now, a lot of what we heard from Dion from an AI model and compute perspective is obviously futuristic, right? What you would agree, but that means you also need the same level of futuristic capabilities in the data center physical infrastructure and how you deploy it. So I'll go start with one quick video, and then we will go into the detail of what all of this means for physical infrastructure. Okay, now you heard about the density, and we're talking about 60 kilowatt as a bare minimum, but at a rack level, this could go with the GB200s even beyond 100 kilowatt, right? Or even more than that. With that said, what do we need to do for the entire physical infrastructure? Now, there are two pieces of the physical infrastructure always for us to remember. There is the powertrain, and then there is the cooling capability. Now, you'll notice on this slide, I'm not talking a lot about the powertrain, not because we're not doing any innovation or evolution there. The technologies in the powertrain to be able to cater to the AI demand already exist today. What's happening there is the multiplication. So the number of power infrastructure type of pieces which you're going to need multiplies by many, many, many fold. But I did want to talk a little bit about the cooling part, because end of the day, when these very dense racks are deployed in AI training clusters and then eventually inference clusters, we have to take out a lot of heat. So basic science first to start with. Air is not capable to take out all the heat which is getting generated by these data centers now. So that's why you need liquid cooling. Now, air can be utilized, but it'll become super inefficient. Imagine creating a data center and trying AI data center and trying to take out the heat with air. It'll be a super inefficient data center. And from a sustainability point of view, that's a huge challenge. Hence, you need liquid. Now, even with liquid, what you need is an overall ecosystem of the data center, not just a solution. So when you see here on the bottom of the slide, the turbo core chillers, and I'll talk to you a little bit more about what's different between turbo core and the regular chillers, but the turbo core chiller, the chiller does the first job, creating the liquid which is required, goes into, as you see on the top, into the CDU. CDU is a cooling distribution unit. This is where the exchange of heat actually happens. It creates that loop which remains on the outside, and then there's another loop which is inside, which is, you see the TCS, which is called the technical cooling system. These two loops of liquid then do the job of taking the heat out from the AI cluster, which is inside the data center. Now, inside the data center, there is, as you know, from a server standpoint, there's talk about direct to chip and there's talk about immersion. When it is direct to chip, the loops inside do the job of cooling down the servers along with the crack units, which work with the DTC, which is the direct to chip. If it is an immersion type of a solution, then your CDU actually is a part of the immersion tank. So that's how this whole solution works. Now, when you think about these technologies, like what you heard, how innovation has played a role in what NVIDIA has done. Similarly, when you think about Schneider Electric, we've been actually doing turbo core chillers for a very long time. Now, there are two very big advantages of turbo core chillers. The first one being the efficiency. These are very, very energy efficient chillers, and the reason it becomes important from a sustainability standpoint is you need so much less of the front-end power infrastructure, whether it's the number of gensets or the sizing of breakers and so on for the entire power infrastructure. But that's not all. Even bigger than that is the fact that for an AI-related cluster, the level of temperature which is needed to go into the CDU and from there to the technical loop system, technical cooling system, is very, very fine. And your normal screw chillers, which you have today on all the large buildings, etc., they actually cannot do that job. Hence, you need a turbo core type of a technology. And I'm really happy because we mastered this technology as a company for more than a decade now. But that's not all. So that's the starting point. Then you have your CDU, which I mentioned does the exchange of the heat, which is equally crucial. Here again, there are two aspects which are very, very important. The first one being the rate flow, the flow rate of the water which is going through. So how that is managed, very fine management of that. And the second is the pressure of the water. So the least decrease of the pressure of water is what is very, very crucial. So CDUs do the job of actually doing the heat exchange. They work with the technical cooling loop, and that provides cooling to the entire infrastructure. So again, taking a step back, you learned about the AI models. We spoke about how dense each one of these servers can get. I spoke to you a little bit about the power infrastructure. I'm not showing it here. Like I said, it's an evolution which has already happened. Technologies exist. But I'm really going deep into what is needed from a liquid cooling point of view. Now, when you wrap all this together, then you create an opportunity to build data centers for the AI environment, right? Yep. Now, the big question is, what are we doing here together, right? You see NVIDIA here, you see Schneider Electric here. What we've done is, we've worked together to build some reference architectures. And maybe, Dion, you want to talk a little bit about what we're doing in that space?
Sure, absolutely. I mean, when you understand that accelerated computing is no longer just about a GPU. It's no longer even about a system. It's really about an accelerated data center. And so we're partnering with Schneider to basically build a reference architecture that allows customers to embrace the accelerated data center at the same speed of innovation that we're developing a lot of these technologies. So again, I think this is an opportunity to basically, help a lot of the broader ecosystem, get ahead of what's coming in terms of the new technologies, and have the infrastructure ready so that when the systems are available, the infrastructure is available, and therefore you can start getting immediate value.
Yep, and we have three reference architectures which we've already built. These reference architectures are both for new builds and for retrofitting existing data centers. They're available for public consumption today. We'll actually be going a little bit deeper into these over lunch today in a separate session. But that's really what we wanted to share together between NVIDIA and Schneider Electric. This partnership, by the way, this was announced at GTC 2 weeks ago, and now we're doing that again here with all of you in the room.
Yep.
So with that, maybe we'll take a step back and see if there are any questions, and if there's anything we can answer. Yeah, there's a question here. They're going to get.
I think they're going to bring the mic. They're going to bring the mic over to you here. Yeah. Sorry.
Yeah. So from the CDU, what's the chilled water temperature going in and out of the rack? Yeah.
Okay. So it's a great question, and I didn't get your name. Sorry, but the temperature depends on what is needed for inside of the white space of the data center. Could be between 23 to 25, but maybe.
Yeah, I believe for the GB200 rack that we highlighted there, it's about 25 degrees coming in, about 45 degrees going out. Yeah.
Hi, Alistair Edwards from Canalys. At GTC, Jensen made quite a big play about the energy reduction in the new Blackwell chips. I think he was talking about a 25x reduction. Could you talk a bit about how NVIDIA and Schneider, as part of this partnership, are helping to drive that energy consumption reduction in, joint reference architecture-led data centers that customers can build?
Yes. So one thing, and that's a great point. So during GTC, we announced when we described our Blackwell architecture, we described some of the energy efficiency benefits as being roughly around 25x. And so for some of these cutting edge inference workloads that require that compute density that I just spoke about to deliver that performance benefit, a lot of that comes from the enabling technologies. I mentioned liquid cooling as being one of them. We mentioned some of the work we're doing around, that NVIDIA is doing in terms of the networking capabilities. So a lot of those technologies are what's enabling that benefit. And I think, as we look at delivering this reference architecture, it will enable people to adopt and deploy that more readily, because you can't just take 120 kilowatt rack and throw it in a standard data center and expect it to work, without really doing some thoughtful planning and upfront sort of build out. So that's really where I think this partnership comes into play, is that it'll allow, end users and customers to really get the benefit day one by having that forethought into the reference architecture.
Yeah, and maybe I'll just add two comments to that. When you're thinking about the powertrain as an example, so one example is when you think of the UPS, which is an important part of the powertrain. So the new UPSs, the GVXLs, which we have today, they're almost 1/4 of the footprint and hence very high in terms of density. So that becomes an important part of the physical infrastructure in the reference architecture. The other example is you mentioned cooling. I explained a little bit about the turbo core. It takes actually almost 2/3 of the energy than any other regular large screw type of chiller. And then going to the CDU, the efficiency with metering and firmware of the CDU increases dramatically, so that you maintain that very fine degree of temperature needed.
And there's also some elements of the architecture that we were very thoughtful about. The fact that we used NVLink and copper-based cabling as the connection points to remove 20 kilowatts of power that's allocated just to the switching infrastructure, for example. So I mean, there's a lot of thought about removing sort of unneeded power consumption and improving the overall energy efficiency. And again, I think at a data center scale, as well as at a system level, rack level, et cetera.
Thank you. So Alexandre from Schneider Electric. So we understand that that the challenge is based on the performance, energy performance. On time, this system thinks that AI can go further by proposing the revenue addition for a colo.
Yeah, that's a great question. Do you want to talk to the revenue model of that single?
Yeah, and that's a great question. I think like I mentioned during the talk, we're seeing data centers are transforming from a cost center to a revenue center. And if you really look at, you can go online and OpenAI, you can go on Barge, you can go on a number of these LLM and generative AI websites, and there are dollar figures associated with input and output tokens. And that is a mind shift, because what you're now doing is when you look at sort of your build out, you're looking at literally return on investment from a revenue perspective as opposed to just a cost item. So I think that mind shift has happened, and that's what's really driving a lot of the excitement around AI. And so, what we've been seeing and working with customers and partners alike is that it's no longer just an academic research project. There's real dollars, there's real sort of business opportunity, and that's where the rush is to really get these systems up and running and to get hopefully the value extracted from them.
Thank you. No, that's good. That's great. Maybe one more question here.
Hello. My name is Manfred, coming from Excite in Stuttgart. We are doing data centers, and my question is a sustainability-related questions. Regarding the temperatures, you said we come in at 25 degree, come out at 45 degree, and if we would raise the temperature significantly, coming out, let's say, at 60, we would be able to do more free cooling. We don't need so much power for cooling.
Right.
And mainly, we would be able to give the heat away to district heating without a heat pump. So knowing that the chip is very hot, is it imaginable that you raise the temperature on the cold plate?
Short answer is yes. I think we're out of time, but short answer is yes. And there are some opportunities to do that, and we're working with customers that are doing that exact sort of implementation. So yeah, that's a great question though.
Yeah, and then you can apply free cooling wherever it's available. I mean, you have to remember it's not available in a large part of the world today.
Absolutely.
But look, thank you for that question, and we can talk more. I think we are out of time, so thank you again for listening in, and happy to answer more questions as we mingle around. Thank you.
Look forward. Thank you. Thank you. Absolutely.